Hello everyone, in this video I want to show you how you can design such connection in CYPE Connect Steel. As you can see here, so I have the UC section, which is here. I have the UC section, UC 254 by 254 by 73, and then here I have the CHS section, which is connected to this plate. This is a plate. Okay, and then here I have another plate which is connected to this CHS section, and also this plate. Here I have the welding symbols, and here also I have another CHS section which is again connected to this bottom of the column, which is here. And then so here also I have another plate here, and for the CHS I have all the information. For the plates, here I have the information, and so I can follow this information to create such connection. So let's get started with CYPE Connect Steel, which is here. So I already created this new file, and from here I'm going to select the member and import the member. So first of all, you need to go to the code. Okay, so using this option here, and from here I'm using the Euro code. However, so a multiple international code including the BS code is available here as well. Okay, so you can use the BS 5950 part 1 as well, and also you have the American code, Indian code, and many other international codes. Okay, so I'm going to use the Euro code. So the next thing is here, so I need to go to the library, and from here I have the materials, and also I have the elements. Let's go to the steel section library here, this option, and click on that. And as you can see, the UB and UC is not included by default, so I can go to the option import a predefined section library. So just click on that, and from here I can go to the European section ranges. Just click here, and here I can go to import the UC and even UB. Okay, so I'm going to import these two sections, accept, and then here I have it. And in terms of the CHS section, so I can go to the tubular sections, and then here I have the CHS, and also here I have another type of pipe profile. Okay, so I'm going to apply and accept this, accept, and then so for creating a new model just like this, so I'm starting with the column. Okay, so here I have the column, and then so I will start with this option. Okay, so here add. So simply I will click on add. So I will say that the truss connection. Okay, and then here I will go to add the members. Okay, the first one I want to add the column, so here, so I will say that the column, and from here or already select the I-beam. Let's say from here I can select the material. I'm using the S275, accept, and from the list here I will go to the UB or UC sections. So here I have the UC sections, and then so I have the 254 by 73, and then accept. Okay, and here I need to rotate my column because my column vertically located here. Okay, so here you have the local coordinate system, as you can see here. Okay, so the green one is the y-axis, the red one is the z-axis, and the blue one, the red one is the y-axis, in the x-axis. Sorry, let me repeat it again. The green one is the y-axis, the red one is the x-axis, and the blue one is the z-axis. So now I need to rotate it about the y-axis, okay, to make it as vertical element. So that's why here I will go to angle with respect to XY plane. Okay, so here I will say that 90 degree. Okay, so I will rotate it just like this, And then so I want to make this one as, I can make it as continuous bar, or I can just leave it like this. So later I can come to here and I can increase the length of this member. However, this is not a continuous member. Okay, so it's ended at the top. Okay, so I will go to accept this, and then so I'm going to add the new one. So here I will say that I have the top chord, which is here. So I will say top chord. Top chord member. So then I will come to tubular sections. I will select the CHS, and then from here again S275, accept. And if I look at here, so I have the CHS 101.6 times 4 mm thick of the thickness. So I will go there, and then so simply I will select the CHS, and then I'm looking for 101.6 times 4, this one. Okay, and then accept. And then here I have it. So if you look at here, so I have the angle of this at 13. So I can simply rotate my let's say CHS section. So I can rotate it again. So as you can see here, I have the x-axis, and also I have the y-axis in this direction. So I need to rotate it about the x-axis. Okay, so again I will go there, and then so I will say that 13. I will search with this. Okay, so if it is not correct direction, so just put one negative. Okay, and then here I have it. So I have this CHS with this location. And then so if you look at here, so I have actually now the location of this CHS, so I need to bring it down, okay, a little bit. So here I will go to model, and then so I need to bring it in the Z axis. Okay, so here I will say minus, so let me try by 200, okay, or minus 125. Okay, so I will put it somewhere here. And then so I need to bring another member, which is the bottom chord, which is here. I have the same thing. And if you look at the distance from here, top chord to the bottom chord, so you can see that I will go to the center of this member. Okay, so and then here if I look at it, so it's about 819, so I will take it as 820. Okay, so I need to go back there, and then so just make a copy of this. So here you have the copy option, just copy, and then so here I have the top chord. I will change the reference to bottom chord. Okay, so now I have the bottom chord, and then so here I have the, let's say minus 820 minus, here I have the 125. Okay, 125. So then I need to take this value. Okay, so here I will say that I have this, and then here it is the new location of this member. So now I have the location of these two members, and then so I will accept this for now. Okay, just accept. So this is the thing, but right now we need to just increase the length of the column to be continued somewhere here. Okay, so I will go to just do right click and then go to edit. Okay, so here I have it. If you look at the column, so here in this window, so you don't have any option to increase the length of the column. Okay, so what we need to do with this kind of problem, so I will just accept this, and then so I will go to the connection option. Okay, just click on the connection. So here I have it, and if you look at the interface, so here you have all the operations. Okay, so the thing that you can do here, so I can go to modeling options. Okay, just click on that, and then here I have the column, top chord and bottom chord. So you can a little bit maximize this, and then here you can see that you have the length of each of this member. Okay, so here for this column I will go to have the 1200 mm, which is 1.2 meter. Okay, and then so I will accept it, and then here I have my column perfectly. So now let's go to the positioning the plate. So here I have the plate, and then if I look at this plate, so what kind of plate I have here, so you can go there, and then this is the plate information that I have. So it is 148 for the width and 970 for the length of the member. Okay, so here I have the plate option, or I can go to end plate. Okay, so I can position this end plate. So just go there, and then so I will select the column. Okay, so I want to have the column. Sorry, here I need to put the top chord. Okay, top chord to the column. Okay, so here it is the position of the end plate right now here. And then the material, again I will select it as S275, accept. And then I have the geometry of this end plate, so the overhang. So right now if I look at this plate, okay, so the width is 101.6 and the y direction or length is 104. Okay, so I need to come with the 148. Okay, so again if you go there, so you have the 148 minus 1.1 point, so how much we have here, 6. Okay, so you have the 46.4 divided by 2. Okay, so 23.2. so that's why here at the left and right, so here I will say that 23.2. okay, and then 23.2. so right now here I have this let's say width, and then so for the y direction I have 104.3. if you look at here, so I have 970. so then simply I will say that 970 minus 104.3, 104.3. so here I need to go for this one, 865 point, let's say, let me copy this. Okay, and then so at the bottom, so I will put this value. Okay, so now I have this one which is here. Okay, so now I have this, and let's say here a little bit, if you look at the drawing, so here you have a little bit of the overhang at the top of the member CHS sections. Okay, so you can say that from here to here is about 8 mm. Okay, so you can also correct this, so which means at the top you can go for 8 mm. Okay, and then so you can, let's say, deduct the 8 mm from here, so which means will become 57. Okay, so here I have the 970, 148. you can see that here. Okay, I'm done with this, and then so let's go for adding another section, or let's say going for the welding. So here I have the welding. Okay, and so for put the welding, so I will go to put the weld first here around this top chord. So here I have the adjust bar, just click on that, and then so I will say that the bar, the adjust bar, which is top chord, okay, to the plate. Okay, the plate 1 here, and then so I will go to add the weld, but right now as you can see no weld is appeared here. Okay, so you can see that there is no weld, but don't worry about this. So just you need to change the position to perimeter. Okay, just here, and then here you have the welding. If you look at here, so you have the welding at both sides of the CHS, but simply you can adjust it using this option that you have right now. Here it is the, let's say, welding. Okay, so the same procedure I want to repeat for bottom chord. you don't need to go to the adjust again. So here you have the copy option. Simply just copy up this, and then so this time change the top core to bottom core. Okay, as simple as that. And then here you have the welding as well. If you want to weld the plate to this column flange, okay, also you can use the weld option. But right now here I can see that in the drawing I have the bolts. Okay, so 1 2 3 4 5 rows of the bolts. So that's why I'm going to this detailing. Okay, so this is actually now the location of the bolts. So I can go to the bolt option, or I can go to the, let's say, the end plate that I have here, and then here you have the bolt option. Okay, so you don't need to use the bolt separately. However, it is possible, but since you are using the end plate operation, so already the bolt option is embedded inside this operation as well. So here you can go to the bolt wizard. You have the bolt wizard, and then so here if you go to the drawing, so here we have 5 rows. Okay, and we have 2 columns. I can go back to my CYPE connected steel, and from here I can say that I have 5 rows, and from here so you can understand how to let's say consider the rows and the columns. So you need to look at the local coordinate system. As you can see here, you have the local coordinate system, the green one and the red one. The green one is the y-axis, and the red one is the x-axis. By the way, if you want to see the sections in the transparent view or solid view, so you can go to the view option. Okay, so here you have the view option, and then so from here you can just make it as transparent view. Okay, so we can go to the transparent view, and here you have the local coordinate system as we said. So the red one is the x-axis and the green one is the y-axis. Okay, so if I go back to bolt wizard, so here also I have the local coordinate system for the plate, and so right now the direction of the bolt should be in the y direction. Okay, so that's why here I have the y direction, but in the wizard the direction of the rows actually is in the x direction. So a little bit I need to understand this and play with this to make the bolt position correctly. Okay, so here we have the y-axis or the green color. Okay, so once again, so here I have 5 rows. Okay, so here I will say that 5 rows here and 2 columns. Okay, and also here you have the other information, which is the SFO and also SF. So again, you need to pay attention to local coordinate system for positioning them. If you go back to the drawing, so here we have the width of the plate as 148, but the let's say center to center of the bolts are 78, and the let's say distance from the edge is 35. Okay, so here we have the 35, and then so I can go back to my software. So here I can say that I have the minus 35, so it's counted actually now from the edge of the plate. Okay, so that's why I need to deduct from the edge and come inside by minus 35. So that's why here I'm putting minus 35. Okay, and then so here we have the 78. So here, so you need to come to the SC, and then I have the 78, and the last one here I have the spacing vertically or between the rows as 125. Okay, so here I can say that 1 25, and then so you can generate the bolts as well. But before doing this, so here we have actually the overall length of the member, and here so the first bolt from the down is minus 210. Okay, so here if I put the value in the y direction, again as you can see, so just I consider 0 and then so see what happened here. Okay, so that's why you need to come up with some negative values. Okay, so you have to position the bolts at the bottom side of the plate. Okay, so simply you can delete the bolts, as simple as that. And then so if you go to the drawing, so here you have 4 spacing with 125, okay, and you have another one as 210. Okay, so simply here you can say that 125 times 4, okay, and then plus 210. Okay, so it means minus 710. Okay, so I can put it there, and then so here I have the location of the bolts. So now to check the position of the bolts and also to make sure that the bolts are exactly follow the drawing, so you can go to the sheet, and then so here you have a cool option. You can go to the 3D Sense, and here you have the sheet wizard. You can click on that. Okay, and as you can see here you have the 3D view, front view, side view, plan view, and also front one. Okay, so front one actually is the plate. Okay, so I deactivated all the other options, but I need to remain the plate. And here you can see that so I have 199.8. okay, however if you look at the drawing, so in the drawing you have the 210. Okay, so here you have the 210, so we need to adjust this. Okay, and you see how from the sheets in CYPE connected steel you can get the exact value. Okay, so you can go back to the model, and then so here you can again delete everything. So here actually you need to change this one. Okay, so if you just deduct the 199.8 from 210, okay, so let's look at it. Yeah, it is 199.8 deduct from 210. Okay, so 210 minus 199.8, so it gives you 10.2. okay, so we need to, let's say, deduct it from minus 710. okay, and then so this is the value that I'm going to place it or key in the bolt wizard. Okay, so we can go back to the model and once again delete everything and go back to the bolt wizard, and then here so just paste the value that we calculated. Okay, and then accept. So now you can go to the sheets. So you see beautifully we have the 210, 125 by 4, and then here you have the 260 almost. Okay, 259.9. and then if you look at the drawing, so here also you have the 260. Okay, so in this way you can simply place the bolts, and then so let's go back to the model. So we just set everything, and then so if I go back to this plate, so here I have one additional plate here. Okay, so let's just go to this view, and then I can go to the, or let's say to add the plate. Okay, so here I'm gonna add this plate. So the grade is S275, and then the thickness, so also you can look at the thickness of the plate. If you go back to the drawing, so just you need to find the thickness of this plate is about 10 mm stiffener. Okay, so simply change it to 10. Okay, and then so you have the plate already located there. So the positioning technique, so I will use the perpendicular and I will attach to the plate, which is front one or end plate, and then so you need to rotate it. Again, you can look at the local coordinate system here. Okay, so you have it, and then so from here I can see that I need to rotate it about the local y axis. Okay, so by 90°. So if you look at this, so here we have the plate, so you can go to different views. So here you have it, and then so now you can play with the size of the plate. Okay, so right now as you can see I have 100 mm by 100 mm. Okay, this is the plate thickness and also plate geometry. So I can just measure the width of the plate. So how much is that? It is 65. I think I made a mistake, so just give me, I think we need to just measure it from here. Okay, so from here to here is about 100. Okay, so 100 mm is the width of the plate. This is stiffener, and then so here I can put the 100, and for the length of the plate, so I can put some value for now, for example 700. So here I have it, and then I need to adjust it. Okay, so again look at the local coordinate system. In the y direction I can just adjust it and then come down. So here you have the displacement in the y-axis, and then so you can shift it down by minus 350 for example here, and again a little bit you need to play with the let's say lengths. So I will increase it to 800. Okay, maybe a little bit more, 900. Okay, and then here we have the location of the plate, and also we need to shift the plate in the, let's say, local coordinate system, but in the z-axis. Okay, parallel to z-axis here. Okay, to position it exactly at the side of the end plate. Okay, so here we can go for 50. Okay, and as you can see here, so the plate is touching the end plate. Okay, and then so we need to cut the plate with the top chord and bottom chord. So let's save the model, and then from here, so one of the technique that you can use for cutting the plate, so you can use the trim plate, and also okay, so here I will go to the trim the plate with the bar which is top chord. Okay, so here I have this, and then so I can weld it. So right now you can see the position of the weld, and later we need to remove this additional plate which we don't need it actually. Okay, for this one you can go to the opening. Okay, so this is a beautiful technique. Go to the opening, and then so from here we say that the element is plate, and this is actually the front plate, but the operation of the opening also is the rectangular. So the origin of the opening, so you can see, for example here I will put, let's say 400. Okay, and also this is actually the position of the x, and then so for the y, so you can say that, for example 400 as well. Okay, so sorry, I forgot to select the plate. Okay, so now here, so you have the plate, and then so here let's go back to 200 just to make you clear about actually the positioning of the opening. So right now for x and y coordinate, I selected 210 and 100. So you saw that where was the location of the opening. If you put 0 0, so it's here exactly at the local coordinate system position or center of the plate. Okay, and now so in the x direction, so the red is the x direction. Okay, from the local coordinate system, so we need to put negative, for example 600. Okay, so is somewhere there, and then so a little bit let's play with this. Okay, so if you look at up, okay, so here you can see that the location is here, but we will say, for example 400. Okay, so here you have the location of the opening, and then so you need to play with the width of the opening as well. Okay, so here we can say 100. Okay, so in the x, okay, so here we have the 100, and for the y width, so we can say that some value, more than 100, or you can put 100 as well. Okay, so here you have the 100, and then so that portion can be easily removed. Okay, so the same operation you can do it for bottom chord as well, but here you don't need to go for opening. Okay, so I will go to the plate cut, just make a copy of this, and then change the top chord to bottom chord. Okay, so here also you have the position of the weld, and for the opening or operation of the opening, so you don't need, because the plate actually was not beyond the bottom chord. Okay, so that's why here you have it. So now almost we completed our model, so you can go to the view option, and then so go to the solid view, and here also we need to place the weld as well. Okay, so you can, for this one, you can go to the weld option. Okay, so here you have the weld, and for the element, so you can change it to plate, which is plate 1, and then connect to weld to plate, which is end plate. Okay, so now here you have it, as simple as that. Okay, so once you have this, so then you can go to the analysis, so you can accept it, and for other, let's say other options, or adding other members, so just you can follow the same procedure. Okay, so you have the end plate, you have the other sections, so just repeat the operations that we discussed here. Okay, so you can go to the analysis. Okay, and then so from here, as you can see, so because we started from scratch for creating this connection, so I don't have any loads, so that's why you can go to the loading, and then or loads, and then here you have the column as the bearing member and top chord, so you can add some forces. Okay, so you can look at the, again, local coordinate system of the members, and here you have the guidance for positioning the load. So for example, here you have the axial force, shear force in y direction, z direction, moment in x, moment in y, or let's say around the x, around the y, and also about the z axis. So you have all this instruction or guidance here. So let's put some tension forces here. Okay, so I'm assigning to the n, which is axial force, in the positive x direction. So that's why here I'm saying 20 kilonewton. Okay, so let's go for bottom chord, put the same load. So here we say that 20 kilonewton as the tension force. So right now just I have these two forces, and then accept, and then so you can run the analysis. So here you have the stress strain analysis, just run the analysis, and so for running the analysis, actually the CYPE Connect steel is using the OpenSees engine, which is a well-known engine for calculating the advanced type of analysis like nonlinear analysis. So here also you are doing the nonlinear analysis as well, okay, considering the stresses and also plastic strain. So after finishing the analysis, so here you have the overall check of the member, and at the bottom side you have the color coding for the utilization ratio with the different colors, green, blue, yellow, orange, and so on and so forth. For example here, okay, so in this case, so you have this bolt with the green color, so which means is a little bit over designed, which means the maximum used capacity of this bolt is about 20%, but for this one, if you look at the color coding of the utilization ratio, so you can see that is about 60%. Okay, so in this case you can optimize the bolts, and also you can look at the weld. So here it is the blue color, and the maximum use capacity is about 40%, so you can just decrease it from 4 mm to somewhere, for example, 3 mm. Okay, and here also you can look at this weld. Okay, so if you look at this, so you are using the thickness of this weld about 4 mm, but the green color, which means the maximum use capacity of 20%, so you can reduce the size of the weld. Okay, in this way you can optimize your operations as well, or connection in overall. Okay, and also you can look at the stresses if you have different load combinations, so you can just track the load combination. You can go for equivalent plastic strain. Okay, so here you have it, and also you can look at the deformation or displacement. You can also scale up the deformation. So let's go to put some let's say exaggerated scale. So as you can see here, I can go to this view, and you can look at the deformation of the connection. So also you can check deformation under stress, under strain. Okay, and also here once again you can come back to the overall check, okay, based on the utilization ratio color coding. Okay, so it is very nice. And finally you can go to generate the summary report and check report of your connection. Okay, so I think that's it, guys, and thank you so much for being with us. Stay tuned with us, and if you have any comment, just let us know, so we'll come back to you. And thank you so much, and hopefully we could transfer some knowledge to you, and we hope also that you learned something by today. Thank you so much, and stay tuned with us. Thank you.